Okay, so continuing the trig ratios. Remember, they call them trig, right? Trig is short for trigonometry. Trig ratios, or they also call them trig what? Functions. The function is like the function of sine and cosine and tangent. Right, we're doing this thing with SOH, CAH, and TOA, right? We started that on the previous notes. And what is this SOH, CAH, TOA? Well, remember the first one is the function. The first one is the function. If you forget which one it is, look at your calculator. If you have a scientific calculator, one of them starts with an S, one of them starts with a C, it's right here, right? You guys see it, sine, cosine? They're here. We're going to be using these and using trig to find angles and measures and sides and stuff. So eventually we'll get to this. But the first letter, S, is for what? Sine. The first letter over here is for, C is for cosine. And the first letter T is for tangent ratio, or the tangent function. That's what the first letter is. What are the other two for? The fraction, the ratio, right? The fancy word for a fraction is a ratio. That's why you learn SOH. You guys see it here? SOH. SOH. That helps you set it up. Okay, we talked about last time. And cosine is A over H, right? The last two letters are the fraction part, the numerator over the denominator. And TOA, the last two letters are tangent, is O over A. Right? That's how we know how to get these ratios and set it up and all that business. Okay. But today, let's see. How am I doing this? Where is it? Let me get this worksheet here. I just had it. We're going to work on this. All right, so you're going to find all three. I know the last assignment it just had you find one. Find all three. So find the sine ratio. This is how you spell sine. Sine, cosine, tangent. I mean, we've been abbreviating them. Find the sine ratio, the cosine ratio, and the tangent ratios. We're going to find all three. Okay. Which is like, okay, well, didn't we do that last time? Well, yeah, but here's the new thing for this. All right. For these triangles here, and what you're going to experience a lot and see a lot is, you're not going to have just numbers all the time. Oh, nice. You're going to run out right now? You're going to run out of ink right now, huh? You're going to have this. Anybody notice what I'm talking about? You're going to have something what? Something new. What is it? You're going to have radicals. Some of these are going to have, these square roots, these radical signs. That's going to be an issue. But we've actually learned how to fix this. So, what are they going to give you? Just an angle like this. They'll put it, remember, they're going to use the little angle symbol right here. Okay. So what do we do first? Label the three sides. Start with the hypotenuse. That's this one right here, right? The diagonal one. Then how do you label the sides? Oh, you look for the angle. You look across. That's the opposite side, O. We got hypotenuse. We got opposite. And then the last one's what? Adjacent. Remember that? Yeah. So, once you label the three sides, we can use SOH, CAH, TOA to remember how to write these. Three trig ratios. So SOH is going to remind me that it's sine of the angle is equal to O over H. CAH is going to remind me that its cosine is what? A over H. And TOA, right? SOHCAH, right? SOHCAH. And then tangent's going to remind you to set up this tangent ratio, which is tangent of the angle is O over A. All right, and I'm sure you can do this, but here's the new stuff. Here's the new stuff. All right, let's see. When you set this up, O over H is going to be 12 over 12 root 5. You guys agree? Yeah, that's right, but it's not finished. And the answer, when you check it on the worksheet or in the book or wherever, it's not going to look anything like that. And you're going to be like, why am I getting them all wrong? You'll see right now. Cosine is going to be what? 24, right? A is 24 over 12 root 5. And again, the answer is not going to look anything like that. You're going to get this answer, you're going to think you're good, you go check the worksheet, and it's not going to look anything like that. And then this one, because of the radical, because of these radicals, the ones when you have a radical in the bottom, yeah, that's why. And then how about this one? O over A. Well, if you put 12 over 24, well, again, kind of for the same reason, it's not going to look like, it's not going to say 12 over 24. Yeah, we can reduce. That's why. If you look for 12 over 24, you guys already know it's not going to say 12 over 24. We can fix this one. This one's easy. Always look to reduce. Always simplify. What is tangent really going to be, you guys? Tangent is really going to be what? Isn't it going to be 1/2? Yeah, if you put 12 over 24 and you look and it says 1/2, you're going to think you did it wrong. You didn't, right? Doesn't it reduce? Okay, that one's already in its simplest form, and it's correct. Everybody agree? 12 over 24 is 1/2. Okay. The same thing is true for these. Look at the whole numbers first. Can you reduce? Can you reduce this? And the answer is yes. What's going to be this one for sine when you reduce it? Radical 5? Close. The radical 5 is in the denominator. Isn't it going to be 1 over radical 5? Because the radical 5 is in the denominator. It's not in the numerator. Okay, and what's this one going to be? 2 over 1, right? Because 24 and 12, the 2 is in the top. Everybody agree it's 2 over radical 5? Yeah. No? Why not? 24 divided by 12 is 2. The 2 is in the top. The square root of 5 is in the bottom. That's still not how the answer is going to look. Okay, so I'm going to leave tangent here, but watch what I'm going to, how you still got to fix this. Lucky Adrian. Sine. I'm going to write it over here. You guys agree we got 1 over the square root of 5? Yeah. You're not going to see that. Anybody know why? Anybody remember why? You cannot have a radical thing like that in the denominator. You got to fix this. Do you remember we learned how to fix this? Ah, you're remembering now. Thank you, sir. We got to multiply by what? Top and bottom by what? The same radical, right? Because when I make 2 of them, it makes it a whole number. You have to have a whole number in the bottom. It cannot be a radical. So really, what's going to be the answer that you're going to see for sine in the worksheets or whatever, or in the book, or what is it going to be? 1 times the square root of 5 is just 1 root 5, or just root 5 over 5. See? This is the answer you're going to see. Let's go back to what you originally had for sine. Look what you originally had for sine. 12 over 12 root 5. If you leave 12 over 12 root 5 and you're like, I got it, and then you go look at the answer and it says this, you're going to be like, what the heck? How is that? That's why. See, that's why. Okay. And the same thing for, do I have to fix cosine? Yes, you do. Look at cosine. Can you have a radical in the denominator? No, you cannot. If it's in the numerator, you're fine, but if it's in the denominator, you got to fix it. How am I going to fix cosine now? Cosine is 2 over radical 5. Well, I think we learned it, right? You guys remembering what you got to do? We got to fix this. We can't have a radical in the denominator. You're not going to see it in the answer like that. So you got to do what? Multiply by radical 5. If it was a root 3, you'd multiply top and bottom by root 3. If it was a root 2, you'd multiply top and bottom by root 2. But it's just root 5. So what are you really going to see for cosine? Cosine is going to really be what? Well, on the bottom, we made it work out to be 5, right? Just a whole number 5, the square root of 5 times the square root of 5. And in the denominator, in the numerator, 2 root 5. Okay? All right. I'm going to stop here. I'm going to continue tomorrow, right? I'll continue tomorrow, so there won't be an assignment yet on this. But, yeah, make sure you finish the other one. Make sure you finish the other one, and then we'll continue the notes, and I'll put a second video on here. All right.